Hello, this is Gary Marr from Wendell Community College. This screen capture is from my CIS 150 AV students online, and in this screen capture I'm going to talk about topics and concepts covered in Section 4 of the textbook. Now, Section 4 is all about code modularization, and what that means is as we get longer programs, we're going to want to break them up into smaller chunks or smaller pieces, kind of like a divide and conquer approach used whenever you've got a complex problem. If you've got something difficult to solve, it's almost always better to break into pieces and then attack each piece individually. For programming, this gives us several benefits. First of all, code reuse. If we break this program up into pieces, we've already done this in class with some of our pseudocode, as we broke up our program into output, processing, and input. If you break something up in pieces, you can reuse a piece in other programs, in other words, save time. This is fundamental when we get into object-oriented programming. This code reuse is really important to the future of programming. Secondly, it allows us to work in team format. If I have my project or my problem broken up into pieces, I can have a different person assigned to each piece, and then we can come together at the end and put all these pieces together. We could be in the same company, or we could actually be in different locations, different part of the country or different part of the world. And then lastly, this benefit of divide and conquer. We'll take a complex problem and make it easier to solve because it's broken down into pieces. So what I've got is 4 examples here to illustrate some of the things that we do with this modularization. Now, modularization also has some other names depending on the programming language. Most languages call these modules functions, or small blocks of code, but Python calls it a def or define. And then also you have words like function or subfunction, subprocedure. Depending on the language, the semantics may be different, but the basic concept's the same. It's a small piece or a subset of the larger problem we're trying to solve with our logic. So what I've done here is the very first example has a function called input, processing, and output, similar to some of the comments I've placed in pseudocode that we've worked on so far. Each one of these functions is blocked off by a function header, which has the return type of the function, the keyword function, identify what it is, the function header or the name of the function, and then also a spot for input parameters. We don't have anything in this example with input parameters, but we will in some of the other examples I'm going to show you. Void is also something which is optional to some languages, and basically what this is saying is that this function, because it's a void function, is not going to return anything. The return parameter is empty. If return had the name of a variable or identifier next to it, then we'd change this void function to either a string or a number. More on this later also. So I have 3 functions, and as this program executes, it's going to put all of these in memory until they're actually called. Because just because a function's defined doesn't mean it's going to be utilized. What utilizes the function is a call to it. So down here on line 38 is really where the processing starts. It's going to call the input module, then it's going to call the processing module, and then it's going to call the output module. So this would be like almost like a hyperlink is on a web page. When it sees input mod, it looks for a function called input mod. Here it is. It'll ask for some hours, sort into rate, and then return back to the call point. Then it does call processing mod. This is where the calculation is done and also some decision structures. Returns to the call point. And then it's going to have to output, which is going to display our answer. This is the simplest of modularized program, and I think if you probably go back and look at some of the other notes, you're going to find that this program, at least initially when we introduced it, wasn't in module form, and what we've done is just gone through and broke it up into smaller pieces. The next part, the next program is Payroll Module 2, it's the second version of this program. It's got a little bit more in it, and it's got some more options when it comes to the actual keywords used for processing modules. So let's look at this one. It's got a module called input mod. It's got a module called processing mod. It's got another function called, or module called output mod. The call statements are down below, but instead of having 3 call statements, it's got 2. So this means this will be running a little bit differently. So the first thing it does is call input mod. Input mod has no parameters. Okay, the parentheses are empty. It's going to return nothing because it's a void function, but it's going to execute these statements. When it's done, or almost done, it's going to call the processing mod. Now there is a mod called processing mod here, and what it's going to do, it's going to pass it two pieces of information: hours and rate, which have been collected from the keyboard, and will be sent out a processing mod to be used as variables inside processing mod. So now in hours becomes one of the pieces of a Boolean expression, and then in rate is used down here in a calculation. When this completes, it's going to return back to the call point, which is input mod. And since that's the last statement in this module, it'll return back to its call point, which is there. And now it'll finally call output mod, which will print our answer to the screen. This one's a little different in that it has input parameters here. It still uses void functions, however. The third example is different still. Okay, this one has a void function called input mod with no parameters. It still has my void function for processing mod with two parameters, but it's going to call output mod directly, similar to what we did last time with input mod. This time it's going to start with a single call to input mod. It'll process all of input mod, go to processing mod, and then finally end up in the output mod. Now, one of the things we haven't talked about yet is the difference between global and local variables, something which will be new to this chapter. It was introduced in a small sense in section 2, but it's really where it's highlighted here with modules. We have three variables called hours, rate, and earnings, which because they're identified outside of a function are global. Now, different languages have different setups for global and local variables, but the most common one is if a variable is defined outside of a module or outside of a function, it's global. If it's defined within the module, it becomes a local module, local variable. So here we have some global variables. But down here, when we pass this information of hours and rate, which are global variables, into this new module as in hours and in rate, anything that is defined within the input parameters are only going to be local to this module, which means that if we were to call input hour, in hours, in rate, down here in the output module, it would fail saying undefined variable. And this concept of input and globals, local and global is very important. You might think it's easier just to call everything global, and that way you can use it anywhere in your program. Well, that's true, but the one problem with that is we'd like to be able to make this code as reusable as possible. So maybe at some point we might want to take this chunk of code here called processing mod and put it in another program. Well, if we keep most of the variables local to this module, then we can move the entire block of code, or we can toggle the entire block of code and have it run on its own. If we start putting global variables in here, now we have to move the global variables when we move the function over to the other program. And that makes it more complicated and also more susceptible to errors. So you're better off dividing your variables into globals and locals. Last example is going to be one that returns something. So what I'm going to do is make one minor changes. Notice this. This function here called processing mod is going to return a number, okay, not a void. And so that means the return statement down here is going to actually have a value with it. It does, earnings. So the way this one will work is it's going to call the print statement with a string literal, and then it's going to take in call processing mod with two variables, 45 and 50. So processing mod accepts two variables, 45 and 50 is in hours and rate, does its calculation, and returns back to the call point whatever is stored in the identifier variable called earnings. So now this statement would say print earnings is, and then the calculated value of this function. There's a lot of variability here with modules. You can have modules that have data types or void. You can have modules that have parameters or have no parameters. There's a lot of combinations there. This tends to be the reason that functions become complicated to understand. In your assignment 5, you're going to have to take your assignment 4 and modularize it, or break it down into pieces. At the very simplest, you could break it down into pieces of input, processing, and output. But you should try to do more than that. You should try to look at your program, and if it does a calculation, in this case of overtime, well, maybe overtime should be a separate module, or maybe it calculates sales tax or quantity discount. They may be good standalone pieces of code that, when put together, make a nice module or function for your application that can be reusable later on. Well, that ends this lecture. If you have any questions, let me know.